Why would you debug C++ assembly when source is missing? Imagine trying to fix a complex machine without a manual or parts list. That's what debugging C++ assembly code feels like when the source code is missing. Sometimes, you're faced with a binary or executable that runs but doesn't give you enough clues about what's going wrong. Maybe you don't have access to the original source files, or you're working with third-party libraries or stripped-down system binaries. In these cases, source-level debugging just isn't an option. Instead, you turn to assembly language, which is the low-level language the computer actually understands. Using a debugger like GDB or LLDB, you can switch from source code to assembly view. This lets you see the actual instructions the CPU executes step by step. You can watch how data moves through registers and memory, which is often hidden in source debugging. This is especially helpful when trying to understand crashes or unexpected behavior caused by compiler optimizations or stripped debug symbols. When source code isn't available, assembly debugging becomes your window into the program's real inner workings. Another reason to debug assembly is when working with optimized binaries. Compilers often rearrange or remove code to make programs faster, which makes source code debugging tricky. Assembly debugging allows you to see the real instructions, even if they don't match the original source line by line. It's also useful for reverse engineering, where you analyze a binary to understand how it works or find vulnerabilities. In embedded development, where code size and performance matter, source code might be unavailable or difficult to interpret. Assembly debugging helps you trace execution precisely in these cases. Modern debuggers support easy switching between source and assembly views. This flexibility means you can start with source code if you have it, then move to assembly when needed. You can step through instructions, set breakpoints, and examine register contents directly. This is especially useful for diagnosing subtle bugs like register misuse or calling convention mismatches. When source is missing, assembly debugging becomes an essential skill for understanding program flow and fixing problems. It gives you a detailed, machine-level perspective that source code alone can't provide. In summary, debugging C++ assembly when source is missing helps you understand what the program is really doing at the lowest level. It allows you to investigate crashes, analyze optimized code, reverse engineer binaries, and troubleshoot issues in third-party or system libraries. Mastering tools like GDB or LLDB for assembly debugging broadens your ability to fix bugs effectively, even when source code isn't available. It's a powerful technique that extends your debugging skills beyond the limitations of source-level analysis.